So, you've plugged in a scan tool, and the code P2097 pops up. It sounds complicated, and honestly, it can be a little confusing. But don't worry. Today, we're going to break down exactly what this common engine code means, and more importantly, what you can do about it.
Ah, the check engine light. It's that sinking feeling, right? It can mean 100 different things. But if your scan tool is pointing you to P2097, we can actually narrow it down quite a bit. So, let's get to the bottom of it.
Okay, let's just get the full name out of the way. Post-Catalyst Fuel Trim System Too Rich Bank 1. Yeah, it is a mouthful, but I promise by the end of this, you'll understand exactly what each one of those words means and what your car is trying to tell you.
Here's our game plan. First, we'll decode the code itself. Then, we'll meet the key parts involved, talk about the common symptoms you might be feeling, investigate the most likely causes, and finally, lay out a clear step-by-step diagnostic roadmap to get it fixed.
First things first, let's crack this code. What is your car's main computer, the ECU, actually trying to communicate with this specific error?
In the simplest terms, P2097 means your car's computer is getting a signal from a sensor in your exhaust that says things are stuck rich. It sees too much fuel and not enough air. Now, the computer has already tried to fix this by cutting back on fuel, but that sensor is still screaming that there's too much. The computer is basically throwing its hands up and saying, hey, I've done all I can, but something is definitely still wrong here.
Okay, to really understand the problem, we need to meet the key players in this little drama. This code really revolves around two super important sensors in your exhaust system.
Think of it like a kitchen in a restaurant. The upstream oxygen sensor, the one before the catalytic converter, is like the chef's taster. It samples the air-fuel mixture right out of the engine and tells the computer, hey, a little more fuel, or whoa, back off the fuel. But the downstream sensor, the one that's triggering our P2097 code, is more like the health inspector. It sits after the catalytic converter, and its main job is to make sure the converter did its job and cleaned up the exhaust properly.
And what about that Bank 1 part of the code? Well, it's pretty simple. On an inline engine, like a 4-cylinder, there's only one bank. But on a V-style engine, like a V6 or a V8, you have two banks. Bank 1 is just the side of the engine that has the number 1 cylinder. A quick Google search for your specific car will show you exactly which side that is. So, beyond that annoying light on your dash, a too rich condition usually comes with some real-world symptoms, things you can actually feel, see, or even smell while you're driving. Of course, the check engine light is the big one, but you'll probably also notice your fuel economy taking a nosedive. I mean, that's all that unburned fuel literally going up in smoke. You might even smell raw gasoline from the exhaust. And performance-wise, you could experience a rough idle, some hesitation when you step on the gas, and in really bad cases, you might even see some black smoke puffing out of your tailpipe.
Okay, so we know what's happening and what it feels like. Now, it's time to play detective and round up the usual suspects, the most common culprits behind a P2097 code. Now, you might jump to thinking it's a bad sensor, but believe it or not, one of the most common and often overlooked causes is a simple exhaust leak. A tiny crack or a bad gasket near that downstream sensor can suck in fresh air, which completely fools the sensor and throws off its readings. Of course, the sensor itself could just be faulty, or it could be correctly reporting a real problem, like a leaky fuel ejector or even a plugged-up catalytic converter.
And here's where it gets a little tricky. Sometimes, the problem isn't with our downstream health inspector sensor at all. The faults could actually be with the upstream chef's taster. If that sensor is sending bad info, the computer might create a rich condition on purpose, and our downstream sensor is just doing its job by accurately reporting it. See how it's all connected? This brings us to the most important part, the diagnostic roadmap. How do you, or your mechanic, figure out which of those suspects is the real culprit without just throwing expensive parts at the problem? Okay, this is probably the single most important piece of advice I can give you. P2097 is often a symptom, not the disease itself. If you have any other code stored in the computer, especially for things like engine misfires or the upstream O2 sensor, you have to diagnose and fix those first. They will very often lead you right to the root cause. So, after you've checked for other codes, the next logical move is a really thorough visual inspection for exhaust leaks. If you don't find anything, that's when you plug in a scan tool and watch the live data from the O2 sensors. That data tells the real story of what's happening. From there, you can test the sensor itself,
fix whatever the root cause is, and then the final step is to clear the code and take it for a good test drive to make sure the fix worked.
And when you're looking at that live data on your scan tool, here's the magic number you're looking for. A happy, healthy downstream O2 sensor's voltage should bounce around a bit but stay pretty steady. If you see its voltage stuck consistently high, we're talking above 0.8 volts. That's your confirmation. The computer is definitely seeing a rich condition. The whole next step is figuring out if it's a real rich condition or just a false alarm from a bad sensor.
So, let's pull it all together. P2097 means the computer sees a too rich condition on bank 1 after the catalytic converter. The biggest takeaway here is to start with the simple stuff, like looking for exhaust leaks, and to always deal with other engine codes first. A proper diagnosis is what saves you from spending money replacing a perfectly good O2 sensor when that wasn't the problem to begin with.
And that really brings us to the final, critical question you have to ask yourself when you see this code. Is the messenger, the O2 sensor, faulty, or is it working perfectly and just delivering an accurate but unfortunate message about a deeper problem somewhere else in the system? Answering that one question is the entire key to fixing it right the first time.